So the next scenario we have is to calculate what happens to pH if we have a weak acid and a strong base. So we have to calculate the pH of 25 milliliters of 0.1 molar of CH3COOH, which is a weak acid, titrated with 0.1 molar of NaOH, which is a strong base. So initial pH. So first we write out the equation for the dissociation of CH3COOH, and then you can look up the Ka value. So that's 1.8 times 10 to the negative 5. So we have our ice table. I stands for initial, C for change, E for equilibrium. So initially we have 0.1 molar, and the concentration of CH3CO minus, the conjugate, is 0, and H plus is 0. So a certain amount is going to dissociate, and this means that you're going to gain that amount on the other side. So from here you have 0.1 minus x, this is plus x and plus x. Using our formula, so Ka equals products over reactants, this is what we have. So K equals x squared over 0.1 minus x. From here we can ignore the change on bottom of the x, so you're going to get 1.8 times 10 to the negative 5 equals x squared over 0.1. When you solve, you're going to get x equals 1.34 times 10 to the negative 3. And what we're going to do is we're going to plug this into our pH equation. So pH equals negative log H plus. Plugging this in, pH, you're going to get 2.87. So next we have scenario 2. So what happens to pH after adding 10 milliliters of base? So first we have to calculate the moles of OH minus. So this is 0.1 molar times 0.01 liters gives you 0.001 moles. Great, that's for OH. And for our moles of our acid, we have 0.1 molar times 0.025 liters gives us 0.025 moles of the acid. So they're going to neutralize. And when they neutralize, this means that originally, our original acid CH3COOH, there's 0.025 moles of it. Since it neutralizes with 0.001 moles, you're going to have 0.001 moles of the conjugate here. This means that you have 0.015 moles of the acid remaining because you have 0.001 moles of it neutralized. So from here, we can calculate the total volume of everything so far. So this would be your 10 milliliters of your base plus your 25 milliliters of your acid. This gives you grand total 35 milliliters. And from here, we can calculate using our ice table. So CH3COOH produces CH3COO minus plus H plus. So using our ice table, ICE, I'm going to write everything. Usually it's in concentration in molar, but in this case I'm going to write moles just so we can see what's happening. So initially, how many moles of CH3COOH do we have? Well, we originally had 0.025 moles of this, but because you're adding acid, you've lost 0.001 of it, and this is how much you'll have left over. So this is why this is going to be 0.0015 moles over our volume, which is 35 milliliters, which is 0.035 liters. In this part, you can just put in molar, which is concentration. So you don't have to show this micro calculation, but I'm showing this here because it's important to to factor in the volume and the new change in moles. And how much of CH3COO minus do we have? Well, we have 0.001 moles, and this is also in 35 milliliters. H plus, we have 0, change, minus x, change, plus x, change, plus x. After you do the calculations, you're going to get 0.043 minus x. This is going to be 0.029 plus x, and this is going to be just plus x. From here, using Ka, you're going to have Ka equals 0.029 plus x. So this is the products over your reactants of 0.043 minus x. You can ignore the change, and by doing that, you're going to get 1.8 times 10 to the negative 5 equals 0.029 times x and 0.043. So I ignore the change for both, and from here you're going to get x equals 2.66 times 10 to the negative 5. And plugging this into our pH equation, so pH equals negative log H plus, when you're finished, you're going to get pH equals 4.57. So for this next question, we have to calculate the pH at equivalence point. This means that the moles of OH minus and the moles of our acid are the same, so 0.0025 moles. So this means that the amount of CH3COOH remaining should be 0 because they neutralize and cancel each other. So from here, we have moles of CH3COH minus, so 0.0025 moles divided by our total volume. So in this case, you would have had to add 25 milliliters of acid and base together. So grand total, you have 0.05 liters of this, and you have 0 and 0 moles left over. Change is minus x plus x plus x. So from here, after you do your calculations, you get 0.05 minus x plus x plus x. Now, in this case, it's important to use Kb to calculate, because in your equation you have OH minus, not H plus. So Kb, usually on your reference tables, they may just give you Ka for whatever acid you have. So this will be 1.8 times 10 to the negative 5. You can calculate Kb by using the Kw equation. So Kw equals Ka times Kb, and so A for acid, B for base, and Kw equals 1 times 10 to the negative 14. So using this ratio, you can find Kb. So in this case, you have 5.56 times 10 to the negative 10 equals x squared over 0.05 minus x. Same thing, you can ignore the change, and afterwards, if you calculate, you're going to get x equals 5.27 times 10 to the negative 6. From here, you can use the POH equation. POH equals negative log OH minus. If you plug this into POH, you're going to get POH equals 5.27, and 14 minus 5.27 gives you a pH of 8.72. What happens to pH after adding 35 milliliters of base? So for moles of OH minus, this means that you have 0.0035 moles of your base. Moles of CH3COOH reacting with OH minus, this means that you have 0.0025, so all of it is going to react with the base. And how much of it is remaining? Well, 35, so 0.0035 minus 0.0025 gives you 0.001 moles of the OH minus remaining, of the base remaining. So from here, the volume, you have 25 milliliters initially of your acid plus 35 milliliters of your base. This means that now you have 60 milliliters in total. So you can actually calculate OH minus, the concentration of this in the solution left over. So you have 0.001 moles of OH minus left over, and this is in 0.06 liters, so 60 milliliters of solution, and you get 0.01667 molar. And once again, using the POH formula, you can calculate POH equals negative log OH minus, so POH equals 1.77. Using the pH formula, so pH equals 14 minus 1.77. This gives you pH equals 12.22.